Hello everybody and welcome back to Calculosity. I'm your host Corey, and today we're going to be talking about one of the most introductory basic building blocks of calculus as a whole, of derivatives, of integrals, and that's going to be the limit. To start though, however, we're going to want to talk about just limit notation. We're going to keep it simple. We're going to go in some small building blocks that are nice and understandable. So we're going to start with limit notation. So, though we don't exactly know what they are yet, we're going to jump into how they write them out. So typically limits are going to be notated as such. So a limit is written using the characters LIM, which stand for limit. To the right of them, we're going to have some sort of function of x or y or n, depending on what we're dealing with. That function could be anything like sine of x, x squared, really any function that you want. We have the freedom to choose or work with whatever we have. So underneath the limit, we're going to need to specify what exactly we are approaching, and we're going to do that by dealing with the variable specifically that we're dealing with. In this case, it's going to be x because we're dealing with f of x. But if this were a function like sine of n, then we could use n as it approaches something. And so we're going to do as x approaches is notated using a right arrow. So as x approaches, and in this case, it's going to be some value. So it could be a, which is just a general representation of some integer or even floating point number, which could be 1 to 5.6 pi. It could be any value. And so this is the general structure of a limit. Now note that we're plugging values into a function, so what's going to come out of this is going to be a y value. Always going to be a y value. Let me not cut that off for you. So it's going to be a y value. Now there are two other types of limits that we're going to want to concern ourselves with, and that's going to be what they call the right-hand limit and the left-hand limit. So we don't really know how it works quite yet, but we're going to get into that momentarily in the next episode. So the right-hand limit is when we're approaching the value a from just the right side, just the side with values that are larger than a, and that's notated using that plus sign next to the a as a superscript. Now if we want to deal with left-hand limits, we're going to say y is going to be equal to the limit of f of x, just like we're used to saying. But now x is going to be approaching a from the left side, from the negative side. So for the positive values, we're going to be plugging in x values that are getting closer and closer to a on the right side. So that's going to be values like if a were, say, 3, that would be values like 3.5 or 3.1 or 3.0001, and you'll see that we're getting very, very close to 3, but never quite touching it. And that'll be important for the next episode. And for the left-hand limit, we're going to plug in values like 2.999, 2.9999999, etc., 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 getting very, very, very close to 3, or any a value. Now, there are also some important things to note, that there are also a couple other limit notations. We have now determined our right-hand limit and our left-hand limit using some sort of a value, but we also do have the option here, instead of an a value, to plug in infinity or negative infinity. So also be ready to see that in some of the future episodes, because these will be important in determining asymptotic behavior, but we're not there yet. So just be ready and be prepared to see this kind of notation in the next couple episodes.